So now I'm going to show you a full example of a dependent samples t-test. So here's my question. Researchers want to test a new anti-hunger weight loss pill. They have 10 people rate their hunger both before and after taking the pill. Does the pill do anything? Use alpha 0.05. Now first of all, note this is a dependent sample because we're measuring the same people before and after. That's why we're doing a dependent samples t-test. So this t-test is going to have 7 steps. First, we're going to state our hypotheses. Then we're going to state alpha. We're going to calculate the degrees of freedom, state the decision rule, calculate the test statistic, and then we will state our results and state our conclusion. So first of all, our hypotheses, our null and alternative hypotheses. There are a few different ways to write this. I'm writing it like this because I think it's the easiest to understand. But basically, our null hypothesis is that the mean before and the mean of after are the same. There's no difference. And then H1, our alternative hypothesis, what we're testing is to see if they are not different. So we're starting with the assumption that they're the same, and we're testing to see if the before and after are any different. Now our alpha, I said use an alpha level of 0.05, that's usually what you will be using. Now calculating the degrees of freedom. This is how you calculate the degrees of freedom in a dependent samples t-test. Degrees of freedom is just capital N minus 1, capital N being the total number of people in your sample. In this case, we had 10 people that we measured before and after. So our degrees of freedom are 10 minus 1 or 9. This test has 9 degrees of freedom. Now we need to state our decision rule. Now we have an alpha of 0.05, which means we're looking for the 5% of values that are rare. So we need to find out what t-score is associated with those 2 red lines I have on my graph. If it's below that or above that, that would be in our rejection region. We can conclude that that is a rare score and that our samples are probably different. Our before and after is probably different. So here is our t-table. It looks kind of complicated, but realize we're using an alpha of 0.05 that has 9 degrees of freedom. So I have those areas marked in red. And that means we're going to use a critical value of 2.2622. So that means we would expect our t to fall within negative 2.26 and positive 2.26. If it falls outside of that, we're going to end up rejecting the null hypothesis. And that's what our decision rule is. If t is less than negative 2.26 or greater than positive 2.26, we will reject the null hypothesis. So let's actually calculate the t now. This is the equation for calculating the t in a dependent samples t-test. On the top you see x bar d. D stands for difference in that case. In this case. So on the top you have the mean difference, and on the bottom you have the standard deviation of the difference divided by rad and rad of the sample size. So actually let me show you what that d is. Here we have before and after, and I'm going to create a new column called difference. So now I'm going to calculate a difference score for each one of these. Just the first one is 9 minus 7 equals 2, and I'm going to do that for each of them. So now I have 10 difference scores for all of the participants in this experiment. And now that we have these, we're just going to forget the initial data. We're just going to use these difference scores to run our test. So first of all, we're going to find the mean difference. We're just going to add together how many scores we have and divide by how many we have. So I add those all together, divide by 10, and I find out that our average difference is 1.7. Now this is the equation for standard deviation. You've seen it before, so I'm not going to dwell on it for too long, but if I put things in here, I find out that the standard deviation of our difference is 1.49. And of course the n is 10 because we have 10 people, so in the t equation I plug in 1.7, 1.49, and 10, and I find out that our t is 3.61. You can just pause this if you want to write down the standard deviation or something like that, but our t is 3.61. So we can state our results now. Remember, our decision rule was that if the t was less than negative 2.26 or greater than 2.26, we can reject the null. In this case, our t was 3.61. That's definitely greater than 2.26. So our result in this case is we are going to reject the null hypothesis. We're going to reject H0. In our conclusion, what this actually means, well, it means that the anti-hunger weight loss pill significantly affected hunger. And then this is how you would actually write the result, t equals 3.61, p less than 0.05 if you want to do it like that. But that's what this actually means. We found out that the weight loss pill actually did something. There is some kind of difference between before and after. And that is a dependent samples t-test.